IHE webinar series. Today is radiology domain. And before I start, this session will be recorded. So is it recorded now? Oh, yep, recording is started. So for those of you participating, please, if you don't mind, please mute your phone so that our recording will be clean. Um, all right, so let's get started. Welcome, everyone, again. So today, our agenda, we have four main topics. The first one is encounter-based imaging workflow. It will be presented by Chris Roth, who's like one of the promoter from the HIMSIMS Enterprise Imaging Group about this work profile, and then Kevin O'Donnell, who is the lead author of the profile. And then we'll follow by import and display of external priors, or IDAP. So Dr. Koff is a big proponent of this work. He'll talk about the clinical background about this profile, as well as Jonathan Whitby. He's the lead author of this profile. And then we'll talk about the clinical decision support or the appropriateness tracking. It is not a new profile, but it has been significantly updated because of the recent HL7 group working together in collaboration with IHE Radiology. So Chris Roth, again, will talk about some of the background, why CDS is very important today for radiology. And then myself, Kinson Ho, will talk about some of the technical details, what is the new thing, update about this profile. And then last but not least, I'll follow up with some recent updates to XDSI that for those of you that implemented XDSI, some of the new changes may be interesting to you. And before we start to the actual profile, so this is the most important slide that you'll see today in the webinar. So you see that as from the standard committee perspective in radiology, we building new profiles. Basically, the new mousetraps that's better to help you solve your clinical problems. But for those profiles to be effective, it is three-legged stool. So basically, we need the standard to support the workflow. We also need the customer or the physicians or the hospital groups that they aware of these profiles and ask for these things when they purchase new system. And then for the vendors, they also need to be aware of these profiles, and hopefully they see that it is beneficial and advantageous to implement this profile, and then they implement it so that the customer can actually buy it. And then this profile can be used effectively. So the main purpose of this webinar is to make sure that this significant profiles that we think they solve real clinical problems are on your radar so that you're aware of it. And when you investigate your problems, if it suits your need, then make sure you're aware of this profile and ask for it. All right, so without further ado, we'll start with encounter-based imaging profile, and Kevin and Chris, you can take the presenter role.
Kenton, thanks.
So let me stop presenting.
There we go. Can you guys see my PowerPoint?
Not yet.
Not yet. Try that again. Better?
Yep.
Great. So Kenton, thank you, and to all of you, thank you for taking an interest in this. I'm a neuroradiologist at Duke, and I help a lot with the informatics that's here. I'm not going to get too much into detail of what encounter-based imaging workflow is. This has become kind of a mainstream conversation point, and there are lots of other webinars and white papers available to highlight what this is. If I was to summarize it in a sentence or two, it's basically we want to capture clinical multimedia of various flavors that we don't want to have to put an order in to associate the images to, and the reasons are several. That it can be really hard to define what body part, what specific configurations of details you want the orders to relate to. All those different things that orders get really clumsy with, you don't want to have to deal with. And in many cases, the variety, the spectrum of the different multimedia that we are capturing doesn't lend itself well to an orders-based workflow. So encounter-based workflow has been successfully employed in a lot of different settings to capture and assign metadata to these basic areas like point of care ultrasound at the bedside with various specialties that do it, photos and videos that can be of any number of different things, normal body parts, abnormal body parts, and when you really zoom in on some small clinical area, a lot of times you don't know what body part it is or what pathology it is, because in many cases people are taking pictures of things that are really abnormal. You don't have the normal landmarks to use. And then finally, endoscopic surgery. Many of the endoscopic still images and video can be tremendously helpful in multidisciplinary conferences and in care planning, and being able to assign important metadata via the encounter-based workflow method, automated without manual effort, is tremendously helpful. So this is not a problem that is unique to medicine. And just for a quick example, all of us today capture images on our phones and personal devices. Back a long time ago, we just captured them and there was very little metadata associated with them, name, size, when it was created, modified. Since then, there's been development of AI that can bucket your photos into various people that you know or places that you've been or things that are in the photo. But really, medical applications of this are not commonplace right now, so we are still stuck manually assigning metadata to some degree. And it's also not a problem that's unique to the technology that we use. This is an article from NASA from 2014 through CNN, where NASA has the International Space Station and satellites all over the place that are snapping photos all over the planet, and they're not assigning metadata to them. So what they did was they asked the citizens of the world to help them identify the body of water or the coastline or the topography, so that there were some metadata tied to these images. So we have to assign metadata. It shouldn't be surprising that Joint Commission, my risk management and compliance group of my hospital, they all expect me to have a list of my data that I've captured, my diagnostic interpretations, attempted invasive procedures that I've performed. They expect to also know the outcomes of those procedures. What was the technique? Was it successful or not? Any complications? And having all of that information in the medical record is vital. And there are a lot of important considerations around this. So the photos are from a building that exploded, unfortunately, in April in my town, and we called it code triage. And there were a small army of care providers, nurses, staff outside of our ambulance bays waiting for the people to roll in. And lots of the people that come to us in settings like this, you don't know their name, you don't know anything about their medical history. You know they're a human being that needs help. You don't know that they may have an abnormal finding in the heart or the abdomen that you're going to take an ultrasound of, and you're going to need to snap pictures of those because they're going to be in the operating room a half an hour to an hour later getting that taken care of, and having that data referenceable in the medical record with some metadata becomes critically important in these settings. Metadata is not the first thing, putting in an order is not the first thing people think about in these settings when there are a half a dozen people crowding around trying to keep a person alive.
Oh, no. Oh, no.
Sorry, but that's the way it is. Putting in various lines and drawing blood, and there happens to be an ultrasound device nearby. So we have to have the ability to very simply put in metadata on the images, whether they be point of care ultrasound or the still images that we capture. And messing up patient A's images with patient B can have some really significant consequences. So the simplicity matters. And again, orders can get challenging in these settings. And this is from a paper that came out in the Society for Hospital Medicine. Just some examples of some of the typical types of procedures that are done in a point of care ultrasound setting. It becomes really hard to bucket all of these into anatomy or other things like that. So using the encounter-based imaging workflow profile in a deployed out systematic way becomes valuable for the hospitalists, ED providers, surgeons who are trying to quickly capture metadata on the data that they are gathering. They have to do it efficiently, not just capture the data, but associate and index various pieces of metadata to the data, the image pixel data that we're dealing with. Patient metadata, name, date of birth, age, medical record number, specific encounter information like who took the picture, who is the supervising doc for the picture, the modality that was used, the procedure, the body part, a unifying identifier like the accession number, and then any diagnostic metadata that's available like an ICD-10 code, structured or unstructured text. And you may not know some of this stuff at the time, but having the ability to do that becomes important. For those of you who are not on the Enterprise Imaging Roundtable for HIMSIM yesterday, if you are interested, I'm not going to get too much into this, but there are new work groups being spun up to dig into the details of many of these aspects across a multidisciplinary spectrum of providers. Because dermatology and wound care and plastics in the emergency department, they all have vested interests in it. So if you are interested in taking a deeper role into defining how encounter-based imaging workflow is used, please do reach out to HIMSS and SIM to be a part of the work groups. Data, the value of data isn't necessarily right when it's captured. The value of data tends to be later by somebody who needs to use the data for something else. And all of us care providers are regularly needing to prove that we are competent. And my hospitals expect me to give this data to them. And can I ask, if anybody is not talking on the phone, I'd ask you to please mute. I'm getting a little bit of feedback. Thank you. Privileging at my hospital requires me to send information on how many times I've performed an exam and the outcomes of my exam, as I've talked about. And the ED providers and the surgeons and others want to have the metadata from the procedures that they're capturing easily available so that they can say, I've done 200 of abdominal ultrasounds. My privileging should go through more quickly than somebody who's only done 5. Or somebody who can't prove that they've done any. I want to get a CME course put into place at my institution because I am qualified to teach this now. And lots of these reasons are why the body part specific piece of metadata are important, because as you're capturing a point of care ultrasound or an endoscope procedure, you assign body part and now it's in the background and you can use that metadata for how many procedures did I do of that body part. So capturing all of it is vitally important, not just for regular patient care, but also because we need to prove that we are doing a good job to the hospitals that we work for, and increasingly to payers and consumer groups who want to define providers into those who are doing a great job and those who may still need a little bit of help. Patient safety is intimately interweaved with this. The screenshot on the left is straight from the American College of Radiology ERAD-Peer, and I'm using it just as a metaphor for the kinds of metadata that are necessary around patient safety efforts. So the college and my institution require what body part, what modality, what hospital, and then various scores associated with how well did I do. And I'll tell you, from turning on quality improvement projects and peer review projects across my institution for point of care ultrasound, that having various pieces of metadata in the medical record to specify specific providers and the quality of their work is vitally important. It's especially vitally important when we identify providers who are struggling, because those providers, we need to get to, let's say, all of their abdominal ultrasounds, and in a regimented, systematic way, go through all of them to go through, really pick out how many times did they miss an interpretation, or how many times did they forget to image something, how many times did they do something that was negative to a patient, because there are remediary efforts that we have to do to bring that provider into alignment of an appropriate level of quality. So having the metadata from the encounter-based imaging workflow for point-of-care ultrasound or endoscopes becomes really critical. And then finally, MD education. Having tied pieces of metadata around body parts or diagnoses or specific provider names at the point of care becomes critical in cases where you are training residents and fellows and medical students and others. So that in a case like the ultrasound cine that's on the left, which is a fetal ultrasound of a double bubble sign, it's a classic sign associated with a fetal anomaly, those are really important for trainees to see. And if they are not captured in a well-indexed, metadata-rich way in the beginning, it can be really hard later to go back and find that case to show all of your trainees. So I wanted to set the stage for why encounter-based imaging workflow is important, what the value is, and with that, I'll turn it over to Kevin, who can talk about the back end of how it would actually be deployed at your institution. And before I do that, let me thank everybody who's been involved in this. This has been a 2-year effort as a part of IHE, and a number of active volunteers. This is not an exclusive group. This is a group who has done a lot of work. I wanted to personally thank each and every one of them because when we deploy these out in our hospitals, doctors' jobs are being easier, patient care is getting better, and medicine's moving forward. So for all of your volunteer work, thank you sincerely.
Excellent. Okay, I will see if I can get screen sharing up here. And so are you seeing presentation now?
Yes, Kevin.
Excellent. So the first thing I want to touch on is Chris didn't actually include himself in that last list, and I wanted to highlight that he was one of the prime movers with the SIMHIMS Enterprise Imaging Work Group that actually kicked off all of our work in IHE on encounter-based imaging with a series of white papers that they put together a number of years ago. So people are interested in the topic. Those white papers are also an excellent resource to start with. So I think we sort of covered this a little bit in the previous talk, but the main point is this came out of the concept of enterprise imaging, that the bulk of what's done traditionally in imaging is what we refer to as order-based imaging. And these are your traditional big iron modalities, your CTs, your MRs, down to echo, and typically performed within departments like radiology and cardiology and driven by an order, which is really what helps knit the whole thing together. But that the HIMSIM work group was recognizing that there was this enormous long tail of encounter-based imaging that was done with, more ad hoc, well, maybe not ad hoc, but, with other kinds of devices like tablets, cameras, point-of-care ultrasound systems, and was distributed across many more departments. And most of those were not, for example, running a RIS or something as a coordinating system. So the focus of this profile was around properly managing imaging that was acquired in the context of an encounter between a patient and a care provider. And as Dr. Roth described, it all comes down to the metadata. We kind of grouped into 4 or 5 classes of metadata that you can see here. Demographics and patient IDs, metadata about the encounter itself, metadata about the procedure, and all of this provides a context for understanding what those pixels mean. And the key point here is capturing JPEGs is great, but those aren't medical documents until you've properly annotated them with all of the metadata. You fire them off into the enormous stacks of the data center, and you need to be able to manage the images. You need to be able to find them again. You need to be able to make use of them. Otherwise, it's just a bucket of pixels. And so really that was the focus of the profile, is how do we efficiently capture the appropriate metadata and manage it together. Now, the good news was that we had a template to work from. That IHE scheduled workflow is, in fact, the first profile that IHE did. Radiology was sort of the starting point of IHE. Scheduled workflow was the very first profile. And it's been rolled out. Essentially, every modality, PACS, RIS, VNA that you buy today has implemented scheduled workflow to coordinate how the orders are passed around, how they're transcribed from HL7 to DICOM, how the modality work lists pass the information down, how that all gets rolled into the images, et cetera, et cetera. And so it's proven to be extremely effective, and most radiology and cardiology departments are finding things are running pretty smoothly today. So the goal was, how do we leverage that? The idea of enterprise imaging is you don't want individual little silos of data scattered all over your hospital. You want to have a imaging infrastructure that the entire organization is using. So from scheduled workflow, we borrowed the ability to query for metadata, standardized storage, and particularly a session number, because in a lot of the systems, that is one of the linking keys between the EHR side of the organization and the imaging side of the organization. So even though there isn't an order, there's still an accession number with each of these encounter-based imaging studies. We added new device. So in addition to things like a point-of-care ultrasound system, which frequently is, an ultrasound system that you would also use for order-based acquisitions, we also added a lightweight device, which would cover things like tablets and cameras and smartphones. And we added the use of DICOM Web, which is a set of parallel technologies to the conventional DICOM that's a little lighter weight to implement, a little easier for newer programmers to deal with. And then finally, result notification, which we'll see in a few minutes. We skipped the order, obviously, and we skipped some of the other details that haven't been sort of heavily leveraged in the organization, like the modality perform procedure step and storage commitment. There's nothing here that's incompatible with those. They could be added, but we decided the first thing was to get the metadata properly managed. And as with all IHE profiles, the idea is that now we have a profile, we can use this to drive vendor convergence. Everybody use the data elements the same way. That you're going to be dealing with a lot of different companies providing this kind of equipment. We need to get them doing things in a uniform manner. So what does that look like? Well, the first pass that we did on this was to look at point-of-care ultrasound. And in a little less real-world view than Chris was providing, you could imagine a clinician in the ER with a patient and decides, I need to have a look with an ultrasound cart that's available in the ER. They pull that over. Perhaps they scan the wristband of the patient. That's going to be the start of the chain. So from the patient, whether it's a name, whether it's from the wristband, the patient ID or the admission ID, you've now got a hook to go get the rest of the metadata that you need. We want to avoid entry by the person operating the system. And so in the case of radiology, we have a RIS that we can talk to. In this profile, we've called the actor an encounter manager. And so the cart then can use that hook, that patient ID or that admission ID, to do a query and to get back a full set of patient demographics, encounter information, whatever the organization currently knows about this patient and their visit. Now, the encounter manager, it could be an additional function that gets built into the RIS. It could be a feature of your EMR. It could be a standalone device that's using one of the other IHE profiles to maintain a list of patients and encounters. Profile decided to leave that up to the implementation. But the main point is that there is a place that the cart can talk to get the metadata. So then everything else is pretty much as usual. You go ahead, you scan the patient. The device can now take the metadata, marry it together with the images, and store those off to the image manager, whether that's a PACS or a VNA. The next step is new, because in order-based imaging, you have the order, the EMR typically is already aware of a placed order, so it's expecting, based around the accession number and the patient ID, that there is a study out there, and if and when it needs to link to it, it can go find it. In the case of encounter-based imaging, it doesn't know that any imaging has been done yet. And so the notify message, which is an HL7 ORU, we wanted to keep these as compatible with current systems as possible, contains all of the information you see on the right, the patient ID, the visit ID, the acquisition time, etc. And the point there is a lot of EMRs will create a phantom order or a proxy order because they like using the order structure to manage studies and to link them into the medical record. We made sure that there was enough information in this notification that they could easily just do that. That would be an automatic process. They don't have to, according to the profile. If they just want to go ahead and index the study based on these, that's fine. But if they want to create that proxy order, they can do it. So you may not have noticed the change there, but same flow essentially for the smartphone and the tablet. So we go from having an ultrasound cart to, say, a tablet in dermatology or a wound care area, and same thing works, that they query for the metadata, they put it together with the images, they fire it off for storage. So the flow is the same. What's different is the technology stack. And so this makes use of what you've probably been hearing about DICOM Web over the last number of years. It's basically the same sort of DICOM push, pull, and query services using web technologies. And so when they do a query, it looks something like this. It's an HTTP call. You can see up in the right, this one's included an admission ID. It said this query is coming from the dermatology department, tablet 1. And it gets back a web bundle. It's formatted using JSON, and you can see they're receiving the patient name, the patient ID, et cetera, et cetera. So the relevant metadata that's known. When it then goes and takes its JPEG image, you can see at the bottom on the right, it's stuffing that JPEG into another HTTP call. In this case, the HTTP is going to the PAC system. It's being flagged that this is DICOM plus JSON structure. So they've essentially copy-pasted the metadata from the incoming JSON bundle into the outgoing. They've augmented it with a couple rows down at the bottom. You see they've included the body part examined, which is the calf, laterality is right. But for the most part, they've just copy-pasted the metadata, they've put in the JPEG image, and you now have a fully qualified image in your PACS. So relatively straightforward. One more abracadabra, so watch carefully the tablet, and same thing would work if you're using something like an SLR. If you imagine in the CT suite, people think of the gantry as the modality. In DICOM terms, it's actually the operator console that's the modality. When we make a CT gantry, it's using completely proprietary protocols to talk to the console, but it's the console that interfaces to the rest of the organization. So in the same way, your capture device, whether it's an SLR or whether it's a dumb smartphone, for example, software deals with how it's going to get the images off it. Might use Wi-Fi, might be put the SD card over, but it's the software then that queries for the metadata and stores it out into the infrastructure. So I won't go through a lot of the details. All of this is in the documents. There's another webinar that Sim put together that you can go hunt up, which goes into a few more of the technical details. Just wanted to highlight here, for example, that in terms of workflow, it's not necessary that the query come before the image capture. So Dr. Roth described a lot of urgent emergency room cases where the first thing is get the image and get the patient moving on their way. And then you may circle back and say, okay, now we're going to upload this thing. Oh, let's do a quick query. Here's their emergency room ID. And so the image capture can happen first, the query can happen second, and then they can go get stored off to the archive. So if you're interested in these sorts of profiles, you'll want to be putting this into the discussions you have with vendors. For example, does the EMR implement the result aggregator in the EBIW profile? Would be a way to ask, will the EMR be able to receive and process these ORU notifications? For an RFP, for example, you might say the modality shall support the EBIW profile as the acquisition modality actor. If you want to confirm conformance, as with all IHE profiles, go look at the vendor's integration statements and check the Connectathon results. There's an online database. If you just Google for IHE Connectathon results, it'll come up. And so you can see which vendors have been starting to implement this, which ones have passed to Connectathon. It's not a prerequisite, but it is a nice litmus test to see that they're getting involved. But all of this is up on the IHE website. You go under Radiology, under Trial Implementation, you can find the EBIW document, whether you're implementing as a vendor or incorporating as a user. And Connectathon is coming every year. So we've had one pass with the point-of-care ultrasound systems, and we're looking to do a second pass this year to start to pull in some of these tablets and cameras. If you do dig in and start reading, I won't go through them, but the top few bullets there are a suggestion on some sections to start with. Profiles can be kind of large, complex documents, so I'd suggest starting with those sections just to get a sense of what's going on. And if you're out looking for integration statements, and this applies to all profiles, there's a product registry, which is hit and miss populated. The Connectathon results are pretty comprehensive. You can search vendor websites. Google is your friend. And please ask our salespeople. If you have an interest in it, put it on their radars, because this is how we get profiles on our roadmaps. The more people out there that ask them about the same thing, the more they start to get the sense that, gee, if we don't have that, probably we should. So with that, turn it back to Kinson. And I think maybe we might be doing questions at the end of the webinar, but I'm not sure. Thanks very much.
Yep. So in the interest of time, maybe if there are any questions for encounter-based imaging, we can take one or two now, or otherwise we can take more questions at the end. Are there any questions? You can unmute your phone if you have questions. If not at the moment, then thank you very much for Kevin and Chris. So the next topic up is IDAP, or import and display of external prior. So Dr. Koff and Jonathan.
All right, thank you. So I'm Jonathan Rippey from Vital Canon, the editor of the IDAP profile. I'll be joined by Dr. Koff. As noted, I'm an employee of Vital. Dr. Koff has no disclosures. And I'll let Dr. Koff start off by speaking about the clinical problem that kind of inspired this profile.
Good morning. My name is David Koff. I'm a practicing radiologist at McMaster University and Internet Sciences. And what I'd like to do is to share with you the pains that we've been going through in practice and give you an example of something that has been my daily life for years. So I will take the example of one of my colleagues, Dr. Smith, a radiologist at a busy cancer center, reporting a large number of CT studies every day, requiring comparison to previous imaging. And these studies are often performed at remote sites, as we have a large regional network with more than 30 affiliated hospitals. So the initial imaging is done remotely, a problem is found, patient comes to the cancer center, and on the subsequent studies, the radiologist will have to compare with previous to report on lesions change, if they change in size and appearance, but also if there has been interval development or resolution of other conditions such as metastatic disease, peritoneal seeding, or pleural effusion, and sometimes not easy to see because it may be very tiny changes or tiny lesions. Also, we need for accuracy and speed to cross-reference the CT slices and MPRs in DICOM format, and Dr. Smith will want to use his own measurement tools. Dr. Smith wants the remote CTs to be readily available in his patient file on his own PACS and want the studies displayed using his hanging protocols. You want the report to be available the same way that he displays the previous report for studies performed in his institution. The last thing Dr. Smith wants, and me too, is to have to access a separate website, even if it was to use a single sign-on. Doesn't want to have to search a separate database. It doesn't want to wait for images to load, as it would slow him down too much through a very busy workday. To make things worse, Dr. Smith may have to open two separate web interfaces, one for the images, another one for the report. At the DR, DR stands for Diagnostic Imaging Repository, which is something popular in Canada. The DR may not be able to move the report with the images. And even if all the studies are stored on the original DR, Dr. Smith may have to ask the remote sign to burn a CD or DVD with the images, and then ask the PACS team to upload the images in the local PACS to make sure that they appear seamlessly. The problem is that this is a slow process. Sometimes it may take 2 to 3 days before the images are uploaded, which means that it differs the time the study is reported. And this is something that our referring clinicians don't like. And it's not uncommon not to have the previous report. And probably the worst case scenario is that at the end of the day, if we're not able to get access, readily access to previous, then we'll end up repeating the study. And that means a lot of useless radiation exposure and repeat studies. So this is what I've been going through in oncology. But again, you find the same issue in many other instances, and mainly in emergency when you need to have access to a previous, and you have to wait or try to use a web interface. This is slow. We had dramatic instances where the fact that we couldn't have readily access to previous on the PAC led to catastrophic consequences, and I'm thinking of pediatric cases which have been really unfortunate. So we've been advocating extensively for the adoption of important display of external priors, because this is really something that we thought would solve a major issue. And I also would like to take this opportunity to thank not only Jonathan Whitby, but Terry Siepel-Schmidt, who has been instrumental in writing the first iterations of this profile, as well as Kinson Ho and Kevin O'Donnell for their support. And now to go into more technical details, I turn back to Jonathan.
All right, thank you. Yes, so Dr. Goff has talked about the existing solutions fairly extensively, so I won't continue with that. So the core goal for the new profile is to make it possible for priors from associated facilities to show up in the reading workflow functionally identically to local priors, so supporting local hanging protocols and viewing tools. So we've tried to automate the discovery and the import of relevant priors and reports from associated facilities, and also to target the existing install base. So the profile makes use primarily of conventional dicombinational 7 messaging. Most local systems shouldn't require new functionality to adopt the profile, and all the complexity is concentrated in the importer actor, which can be an add-on to an existing system. There's also fairly minimal shared infrastructure required. I'll talk about that as I go along. At the high level, the IHE Profile has, so on the left you have the local site, and on the right you have the set of remote facilities that are part of the IDEP sharing arrangement, and the importers in the middle. The trigger for the workflow is a conventional procedure scheduled message, which is sent to the importer. and then it uses that to take the patient information from their procedure scheduled and identify the local patient identifier used for each of the remote sites that it's sharing with. It then uses that along with the procedure information to find external studies at each of those sites. And then it will filter those for relevancy and also for duplicates, and then retrieve priors to itself. And then the importer does a critical step, which is to localize all of the prior reports and images. So to use local patient identifiers, wherever possible to change to local procedure codes, and also does some additional coercion, such as labeling, making sure they're labeled with the correct institution and other tags to flag them as external studies to help with the lifecycle management. And then those are stored to the local image manager and to the local report manager if that's a separate system. So this is a simplified view. To go into a little more detail, so as I mentioned, the trigger is a conventional procedure scheduled message, so such as used by the scheduled workflow profile. For identifying the remote patient IDs, in the ideal scenario, you'll have an EMPI and with PICS capabilities. So from the local patient ID, I can just query the PICS to get all my other patient IDs for the associated sites. But if that's not the case and you don't have that kind of shared resource available, the profile can also make use of a patient demographics query or even a DICOM query to look up the local patient IDs for the current patient. So again, this is one of the areas where shared infrastructure simplifies things, but it's not strictly necessary. The importing of external priors, or the identifying of external priors, is just conventional cfind, although we have defined an enhanced query option such that a kind of existing PACS should be able to support the basic workflow, but if it has support for additional query keys, such as more body part and procedure information, then you can do more effective filtering at the query stage, which just simplifies the whole process. The prior relevancy is determined based on combinations of modality, procedure codes, anatomic regions, etc. And the IDEP process also not only filters for duplicates, but also involves checking the local system to see if the studies are already there or if they're complete, so that if you aren't constantly re-importing the same data if it's still stored locally. The localization, as discussed, of course, is to local patient identifiers and procedure codes, etc. And the report retrieval is an important component of IDEP, as that's one of the things that existing solutions have struggled with. So from having identified a set of relevant priors, then the accession numbers are used to retrieve the associated reports via the MHD profile. So as part of participating in an IDEP report sharing, then facilities need to work out a way of making their reports available to an MHD document responder. And the report formats are specifically using text and PDF radiology reports only. So try to narrow the scope of the reporting to make it as easy to support as possible. And similarly, reports go through a localization and conversion step. IDEP also defines kind of purge workflow for priors and reports. So all the external data is tagged in such a way as to make it easy to identify as external data, and then the profile has suggestions on how this can be tied into lifecycle management to avoid having to store external data indefinitely. One thing to note, IDEP does not require XDS. In some ways, then if you are participating in an IDEP sharing arrangement, it's like a lightweight affinity domain, but XDS is not required. However, XDS is defined as an option within IDEP, such that if sites already have an XDS infrastructure set up, then you can just make use of that as part of the IDEP profile. So IDEP still defines the workflow and the triggers and the coercion of data, but XDS is used for the actual querying of data and the movement of data. So it can make use of an XCS infrastructure if one is in place, but it's not necessary to the process. So a couple of other key points. So in IDEP, then it's expected that any site participating in IDEP will participate in both sides of it. So a site will not only initiate the retrieval of priors from other sites, but they'll provide priors to each site. So in any given transaction, a single image manager acts as either a local image manager or a remote image manager, but then they will swap roles in other transactions as well. The importer and other key infrastructure pieces can be centralized. You could have one importer that all the local hospitals are tying into, or you could have that implemented at each site and just functioning independently, although essentially doing the same thing. And wherever possible, we've tried to leverage existing profiles such as the import reconciliation workflow, PIX and PDQ, MHD, XDS, and the transmission of reports to the local report repository is modeled on the results distribution profile. So those are, while they're retrieved as via MHD, then they're stored in the local system as conventional HL7 ORU messages, which should be the most supported report format around. So the supplement is in trial implementation stage and can be found on the IHE website. There's also the IHE wiki has been updated to include information on this profile. And again, I think, are we doing questions at the end or at this stage?
We have time, so if there are any questions right now, we can take 1 or 2 questions. And also, if people think of questions later, we can also take more questions at the end. Any questions right now? Please unmute your phone if you have a question. If not at the moment, thank you, Dr. Koff and Jonathan.
Thank you. And yes, thanks to Terry Sippel-Schmidt, who wrote the first draft of the IHE profile, which I then took over. So,
indeed. Okay, so the third topic that we are going to cover today is clinical decision support. It will be Dr. Roth and myself. So let me present. Yeah, go ahead, Chris.
Sorry, I was muted. Thank you, Kenton. So this is a very timely one. Most of you are probably aware of the clinical decision support mandate, and if you're not, I would refer you to the web link in the center of this screenshot. It was put out by CMS, but it's actually remarkably readable for something that comes from government. The short of it is that any, I'll say, expensive imaging procedure, CT, MRI, nuclear medicine, PET, is going to have an appropriateness score associated with it beginning in January. This is part of the Protecting Access to Medicare Act that was passed in 2014. The legislation is on the right. And what it highlights is that, I think anybody in clinical care is aware that some of the procedures that we perform are high yield and some of them are less high yield. The intent behind the legislation and the installation of clinical decision support software at the point of ordering is to gather up appropriateness scores internally to an institution and then share them back with payers and other stakeholders so that we can start stratifying who is doing a good job ordering the right studies and who may not be. The way this is going to be done is integrated into electronic health records and other methods of ordering studies will be a system where you pick a procedure, let's say a CT of the cervical spine without contrast, and a specific structured indication, radiculopathy or neck pain or something like that. And then a message goes out via web services or some other method, bumps up those two items, the procedure and the reason for exam, against the appropriateness guidelines that are put out by organizations like the American College of Radiology or American College of Cardiology, National Comprehensive Cancer Network, the Society for Nuclear Medicine and Molecular Imaging, the American Board of Internal Medicine with Choosing Wisely, those sorts of bodies that create guidelines and scores around when to perform certain types of imaging. And then a score comes back from the organization's guidelines that are hosted by a third-party vendor to the institution and assigns a score, let's say between 1 and 9, to the request for imaging that was just placed. The reason for this profile is at my institution, I get orders from all kinds of sites that are not on my electronic health record, not using my order entry system. It may come in through a phone, or it may come in on a piece of paper or something like that. And my institution, is going to be responsible for highlighting the score that was put out with that study with respect to appropriateness. Let me get a little more specific. The score is assigned to the provider that ordered the study, but I'm potentially the one that is at risk for not getting reimbursed if that was a study that was deemed to be inappropriate. The medical necessity denials or peer-to-peer risk falls typically on the ordering physician, but in terms of reimbursement after the fact, if we perform an exam that is low yield, as defined by the national guidelines, it's potentially the performing institution, the imaging department, that is at risk. So the intent behind the profile is to be able to communicate scores that are gathered in one organization, let's say, or at one physician office, and convey them to other organizations that may be doing the imaging, so that beginning in January, we can start gathering data and sharing data with organizations around the country that care about them, whether it's a third-party payer like Medicare, United, Aetna, or patient bodies. And my organization and many others have put together, data marts and dashboards and things like that we can start sharing out with our internal providers for how commonly appropriate or inappropriate a given provider's studies happen to be. And you can compare them in terms of scores against other providers. And this is something that we're doing that we've been successful at, where if you take a look at the first 3 providers on this this chart. So what this is 12-ish providers at one Duke clinic of the scores that they order, and this was pulled from about a year ago before we made some operational improvements. And what you find is that there's a wide spectrum of utilization. There's a wide spectrum of appropriateness of the studies that they order. And we've taken some very tangible, very good steps to improving the heterogeneity, so that when the requirement is in place January 1st of 2020 to share Duke's data or any of our data around ordering, that we're going to be putting our best foot forward. So the point behind the profile is to be able to share data between systems so that the loop is closed from the point of ordering to the point of performing. This is a big deal to lots of imaging departments across the country. The amount of money potentially at risk for not having a system like this in place at Duke is in the 8 figures. So I want to thank all of the IHE members for putting this in place for all the care providers who are going to be beholden to the requirement in the near future. With that, I'll turn it over to Kenson to talk more about what the IHE committees did.
All right, thank you, Dr. Ruff. So let me present. All right, can you see my slide?
Yep.
Okay, thank you. So my name is Kinson Ho. I'm a solution architect in Change Healthcare. I'm also currently one of the technical committee co-chair in radiology. So thank you, Dr. Ruff, for very detailed background information about the clinical importance of CDS-OAT. So now I'm going to talk a little bit more about the technical side, about what the profile looks like. Um, so uh, Panama, like Chris already talked about it, and specifically there are certain information that is required in the information flow so that the scoring can be communicated appropriately. So, for example, the MPI of the ordering provider, which CDS mechanism was being used, and the score, whether the consult is adhered to the best practice, does not adhere or does not apply, which Chris already mentioned. So those informations are very important to make sure that they are appropriately communicated from one system to another. Otherwise, like no money will get paid, which is a huge problem. So this profile, CDSOAT, is making sure that those information can flow through different systems, and it taking advantage of many of the existing profiles like schedule workflow, which already define the mechanism communicating between the ordering order placer, DSS order filler, the image manager, and down to the other system. So this profile is mainly augment those existing messages, especially all the HR7 messages, with OBX segment that specifically communicate the information related to clinical decision support. The message specification that defined in CDSOAT, there's a paragraph that explicitly stated that the message specification can be used within this CDSOAT profile or standalone. This is kind of unique for this CDSOAT, and it has been updated in the recent text. Oh, sorry, one thing that I forgot to mention. For those of you that are following IHE Radiology closely, you probably have already seen CDSOAT as a trial implementation profile for a while. It was published a number of years ago when we first becomes aware that the CDS is coming up for the CMS regulatory requirement. And at that time, we put our best effort to think what may be required for the messaging because some of the details are not completely defined yet. But we try to have a foundation layout. And now the regulations, they come up with the final rules and with more specific of the informations. Then IHE Radiology, we collaborate with the HR7 order and observation group, and many participants in that HR7 group has interest in make sure this works in their system because this is one of the main factors in their system. So we collaborate very closely to make sure that the messaging are rich enough to capture all the information, especially is updated to capture the new information from the final rulings. So CDSOAT has recently been updated again. We just published a new version this year that captures the new information with the new specification of the OBX segment. And we added a new tag specifically saying that for system that use CDSOAT as a workflow profile, so it uses all the transactions in schedule workflow with the addition of the OBX segment. That's great. That's one of the approach. But for other system, like for example, for the EMR that needs to convey the CDS information down or receive those information, they can also use the message specification defined in section 6.4 as a standalone message specification, and because that is the core part of the CDSOAT. Some of the integration workflow it is good, but we know that some of the existing hospitals, they don't necessarily follow straightly about some of the workflows, but the message specification to communicate the CDS information is still perfectly valid and usable in other contexts. So for those systems, for many of the audience in this webinar, if you fall in one of the two camps that needs the CDS information, this profile is still highly valuable for you. So the main goal is to make sure there's a smooth implementation across the board, and make sure that the information is communicated appropriately. And the way that the profile is structured, so that like all the coding system required is not specifically defined for US, but it can be generalized for other non-US use. So some of the US specific details, you see that it's separately highlighted that in the context of US, then these are the specific code that you should use and things like that, and all defined within the profile. So the core content of CDS OAT, this profile, is a new section. This is the section in section 6.4, and this is a table that extracted from that section. This is completely rewritten from the first release of the profile. So for those of you that has looked at the previous publication of this CDS OAT profile, please make sure you download this new version. The content specification is completely rewritten in section 6.4, and it specifically it uses version 2.9 of HL7. And the version 2.9 of HL7 is only used for this particular OBX segment for CDS information. Other OBX segments are still using like 2.3.1 or 2.5 specification. We specifically highlighted this because some of the specification in this segment, the data type and the content, they have a slightly different specification than in the earlier version of HL7 2.3 and 2.5. So in the MSX segment, you'll see that there's a OID that defines whether this CDS related OBX segment is in the message or not. If so, then make sure your interface engine or whatever handle the HL7 processing, make sure it can handle this particular CDS segment in the version 2.9 fashion. In the profile, I'm not going to go through it in details today, but it has lots of details information for each of the field, defined here what information needs to be put there, what are the conditions, things like that. So please go and download the profile and take a look if you are interested in CDS OAT. And as Chris also touched on, ONC actually referenced this profile in their website. So so it is important to follow the standard and make sure the information, the CDS information, is communicated appropriately. So any question about CDS OAT? We can take a question or two if you have any. If not, then we will switch to the last topic for today. So it is about XDSI. There's some recent enhancement to XDSI. I know many of you implemented this integration profile. It's been one of the great success recently in radiology. So because of the heavy use of this profile in many different regions, we get lots of feedback, and there are a number of enhancements that we made recently that I would like to highlight today. There are two recent CPs, both of them has already been incorporated into the technical framework. So if you are going to download the technical framework, we're just about to release a new version, revision 17 of the 17 or 18 of the technical framework. So make sure you go the next couple of days to the IHE website to download the latest version. So the two CPs that recently we updated, one is that we introduced a new reference ID option. So for those of you that are familiar with XDSI and especially the metadata structure, currently we support a session number in the event code list. We now also added the support for study instance UID in the in the reference ID list, not in the event code list. So in the reference ID list, it already supported a session number. Now we added a new ID for the study instance UID. Before this CP, I know that many implementation, they added their own proprietary extension to introduce study instance UID in the XDS metadata. So now there's a standard way to provide that information. The second major thing that we added is a new delete imaging document option. Previously, it has some like high-level text that say if the study in your imaging document source has been deleted, somehow you need to delete the study in the registry or the repository, but never mention how it is supposed to be done. And recently, we did just say like it should be using the ITI metadata update profile, but then even the ITI has recently updated how metadata update should be handled. So this CP now catch up with all the changes and explicitly now it make use of the ITI remove metadata and document profile, the RMD profile, by grouping with the document administrator actor. We chooses the delete option. So that means with this delete imaging document option, both the metadata and the document will be deleted from the registry and the repository. And it can handle both the manifest and the report. So for those of you that are familiar with IHE radiology domain, especially on the imaging side, you probably also heard about IOCM, or Imaging Object Change Management, which is also a mechanism that allows a system, an image manager, or a change requester from the profile perspective to communicate changes of a study to a downstream system, another image manager. So now with XDSI integration, there are two kind of like similar paths using this new delete imaging document option, or IOCM. And so I want to highlight what are the differences between these two options. So with the delete imaging document option, the new option that we introduced recently, as I mentioned earlier, both the metadata and the document will be deleted. There's an explicit request using the ITI RMD profile to delete the metadata from the document registry and to delete the document from the document repository. Using the IOCM option integrated with XDSI, which is documented in the IOCM extension, which is still in trial implementation, the method is the imaging document source or the image manager that support IOCM when they made the changes to the study. It will create a rejection note for the study to reject all the objects inside the study. But the study still has a rejection note. That object or that DICOM object still exists for the study. And because of that, instead of deleting a document or the manifest, it actually creates a new replacement manifest for the existing study. And the new replacement manifest has only one object reference in it, and that is the rejection note. So technically, that is the main difference. And what does it mean? So using the delete imaging document option, what it means is that the study manifest is permanently removed from XDSI, both from the registry and the repository. That means any subsequent query or retrieve you won't be able to find that study anymore because it's actually deleted from the XDSI infrastructure. On the other hand, if you're using RCM integrated with XDSI, the study it still remains in the XDSI infrastructure. There's still a manifest there, and the manifest only reference the rejection node, but none of the imaging objects anymore. Uh, so in case that there are other downstream system like a RCM-enabled imaging document consumer, which has already cached a previous copy of the study, for example, then when they try to retrieve it again, for example, they will detect that there's now a new manifest which has a rejection node in it. So since it is RCM enabled, it can actually apply the RCM rejection node and reject the local cache copy accordingly. So both methods, they have pros and cons. They have a different approach, but they are both valid and supported methods. Depends on which mechanism your existing system already support. Some may be already supporting RCM, some may not. So you can choose one or the other. Depends on your need. So we have covered the four main topics that we would like to cover in this webinar: the encounter-based imaging workflow, import and display of external priors, CDS-OAT, and some of the recent enhancement in XDSI. So back to this slide that I talked about earlier during the introduction, we highlighted some of the new mousetraps that we have developed. So the standard profiles give you a standard mechanism to solve some of the clinical problems. Now the ball is on your court. As I mentioned earlier in the introduction, now we have the better mousetrap. We need to make sure the customer aware of that so that they can ask for them in their RFPs, and the vendors are aware of that so that they can implement it. If it helps them to solve the clinical problems, implement it in their product so that the customer can buy it. So hopefully these are important profiles that will soon be in your radar, and hopefully we can see that some of this profile will be adopted and used in real clinical setting. So just to reiterate some of the information that Kevin mentioned earlier, for the customer side, make sure in your RFPs you have some languages like this one to ask for a profile. This is an example for EBIW, but for IDAP, for CDS-OAT, for other profiles like RCM or any other profiles in IHE Radiology, you can develop similar RFP style languages to make sure you ask the vendor what they support, including good context, what are the use case, how you want to use the profile to solve your problem, and ask for them in your RFP. And you can check the vendor's integration statement or the connectathon results to see what's the level of support of these profiles or whether they are in the roadmap of their implementation. So again, just to reiterate, you can always go to the IHE website, go to the technical framework, and you'll see all the different domains. And if you go to the radiology domains, then you'll see our new supplements as well as the existing technical framework with many of the well-established profiles. Then you can look at some of the trial implementations or the technical profiles to read up the contents, to find out the specific details information. So this is highlighting the EBIW, but other profiles, as you see here, CDS-OAT is also listed there, and RCM extension is listed there as well. So you can find all the profiles that has been published by Radiology on the website. So that's all the prepared contents for today's webinar. So now open the floor for any questions for any of the presenters today.
Question from Charles Parizeau. Can you hear me?
Yeah, Charles. Hey.
On your last CP, I think very interesting indeed. Deleting everything applies in certain policy environment where the patient has required that the data be forgotten. In usual health record, you want to keep things as deprecated records, but you want to keep them as part of the XDSI registry and repository. The part that I did not understand well is that the original manifest that points to the original image. What do you do with that manifest? You replace that manifest by an IOCM, or you make a new manifest deprecating the old one that points itself to the IOCM for the study?
Let me
I
go
missed
back
that
to
point.
that slide. So if you're using the delete imaging document option.
No. I'm on the IOCM side. I understand
about the IOCM side? Oh, okay.
I'm on the IOCM side. What I don't understand is there was a XDSI manifest pointing to 3 series.
Yep.
What happened to that manifest? Is it now it is becoming deprecated and replaced by the IOCM object?
That's not by the IOCM object. So the manifest originally referenced the study. Let's say the study has 3 series, 10 objects each, like you said. So there's an existing manifest that references that study with the 3 series with all the 10 objects. Now that study is deleted.
Yes.
You have a rejection note that the rejection note itself will say these 3 series and these 10 objects in each of the series are rejected now. So that rejection note itself is a DICOM object. The imaging document source will now create a brand new manifest that references this rejection note, and this new manifest will use to deprecate the existing manifest and use as a replacement a new one.
Okay.
So the existing manifest will now has a deprecated status. A new manifest will be published to XDS, and the new manifest will only reference the rejection note, and the rejection note will reference the rejected objects.
Okay, perfect. Very, very clear. And I think this is indeed a great extension to XDSI. Thank you.
Yep. No problem. Thank you for the question. Any other question?
Not a question, but I guess just a reminder for implementers that I think the Japanese Connectathon is coming up second week of October. Registration for that is probably already closed, but there'll be a Connectathon in North America in January and one in Europe in April. So you can go looking for those to test your implementations.
Indeed. Any closing remarks from any of the presenters or from Chris Carr? Have any comments before we close?
I just want to say thank you. This is Chris Roth. I want to say thank you to all the folks who are involved in this. This is my first year as the planning committee chair. I especially want to thank Mike Bowl for all of the work that he's done as part of IHE. Mike is beginning, or actually has rotated off, and recognizing everyone on this call, recognizing those who are doing a lot of work on the technical committee. Mike, there's very good work coming out of IHE. There's very good work that is directly applicable to all the hospitals that one day all of us will be patients. So we're moving our own field forward, and I personally thank you guys for all the work that you've done.
Thank you.
Hey, this is Chris Carr. I was double muted earlier, sorry, but I just echo what Dr. Roth just said. Thanks to everybody who has contributed to the work that was presented here today and to the presenters themselves, and also to everyone who attended for your interest in these subjects. And as I think has been indicated a few times, this is intended to be an open and accessible process, and we hope to have as broad engagement as we can from both users and developers of radiology systems. So if you aren't currently engaged in committee activities, we certainly would welcome your participation. Thanks.
Okay, thank you very much. If there's no more questions, then I think we are at the close now. Thank you for your participation again. Hope to see you next year at the webinar.
Sounds good. Thanks, everyone.
Thanks, everyone.
Thank you.
Bye-bye.
Bye.
Thank you.